What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we're going to take a look at one more example of finding the equation for a hyperbola, given the vertices and an asymptote. So let's go ahead and grab our pens, paper, some graphing, and let's go. So here's a situation we're presented with. Find an equation of a hyperbola whose vertices are 1, -3, and 1, 1, and whose asymptote is, and then they give us this equation, y plus 1 equals 3/2 times quantity x minus 1. So let's start to sketch, shall we? So we're going to graph our two vertices that were given to start with. And one is going to be at 1, 1, 2, 3. One is going to be at 1, -3. And the other one is going to be at 1, 1. So I got a vertex there and a vertex there. Now, what's really cool about that is two things. Because I got a vertex there and a vertex there, that tells me, in general, I'm going to have one of these hyperbolas that goes in the direction of up and down. So I know that part, which means it's going to be a y squared minus x squared one. Woohoo! So we know we're going to have that kind of idea behind this one. So I got to figure out what the center is. Well, the center is halfway between the two vertices. So if I can count correctly between these two values, I can find them. I could also analyze the distance. If you want to do more of a formulaic approach, I could say, well, what's the average between -3 and 1? So you could also add those two values up, -3 plus 1, divide that by 2. And -3 plus 1 gives us -2 over 2, which gives us a value of -1. But it's like, oh, well, that value, -1, would be right here. So it's going to be on that line that includes the vertices. So my x-coordinate will still be 1, but my y-coordinate would be -1. So my center, so this is so cool, so my center is going to be at 1 and -1, boom, shakalaka. So let's start to put this together, shall we? So we're going to have, I know it's a y squared one, so we're going to have the center, we're going to have y plus 1 squared over something, plus, or no, not plus, that's the ellipse. We're in the hyperbola, we got the x minus 1, that quantity squared, and that's going to be equal to, we know we always set that equal to 1. So I just got to figure out the a value and the b value. Well, now that I know where my center is, I can figure out this distance from the center to the vertex. And that, whether I go up or I go down, that whole distance from one to the other one, that distance from there to there is 2. And 2 squared, so that's going to be my a value, is going to be 2, which means 2 squared is going to be 4. So that's my a squared value, which goes underneath the y. So I'm going to put a 4 right there. Now, for the rest of it, now this part right here, we can take a look at a couple of different things. Now, this value right here, this is going to be one approach that you could look to it. So right there, we can come up with something to help us find the b value. And we'll talk a little bit about that because we could have also pulled the center not only from our picture, but if you look at the way this equation is presented, we've got our hk kind of components right here. So this would be h and this would be k right there, which means, you know, we could have analyzed the center from that component instead of counting and just said, yeah, my center is going to be at -1, 1. So either way you think about that, that's pretty cool, right? But to figure out, all right, so now to find the b value, we're going to use the slope, which is very nicely given to us in front of the x minus 1 quantity. So that value, now since we know this one goes up and down, it's an up and down hyperbola, that means the version that we're going to use, so to find b, or actually not b, but b squared, all right, we're going to take that 3/2, that slope that we're given, and we're going to set this to, and this is where you kind of have to think about it a little bit. This one is going to be in the a over b version. So the a value, like we know what that is. The a value in this case, we figured that out. That is going to be 2. So 3 over 2 equals 2 over b. So I'm almost there. All right, so then I cross multiply, and I'm going to have 3b equals 4, and then I'm going to get b equals 4/3. Which means when I square that, so let's kind of keep going here, so that means b squared is going to be 16 over 9. You with me so far? Cool. So now I'm going to write that up there. So 16 over 9 goes here. However, we can't have a fraction on the bottom when we do this, so we only have one more step to go to actually write the equation of said hyperbola. So we're going to keep everything the same on the y. So we're going to have y minus or plus 1, that quantity squared, over 4. Minus, and then that fraction, 16 over 9, we're going to flip that, kind of, sort of. We're going to make that 9 times x minus 1 squared over 16 equals 1. So the final version of our hyperbola would be this guy right here. Y plus 1 squared over 4 minus 9 times quantity x minus 1 squared over 16 equals 1. So that is hyperbolas for today, boys and girls. Thank you so much for watching. And as always, get out there, be awesome, be kind, and be generous to all those around you. I'll catch up with you later. Make it a great day. Peace out.